Berlin this side. So welcome to the first video of the channel Maths with Berlin. In this channel we will be focusing on primarily the competitive exams for mathematics like JEE and Olympiads like pre-RMO, IOKM, RMO, NMO. So let's get started with the first video without any delay. So for the first video, as you can see, we have chosen a problem of limits, and this is a very good problem from my perspective. Let's see if you can solve it. So you may give it a try or check out the solution. No, I would suggest giving it a try, right? Because it would enhance your concepts and also your confidence if you can solve the problem. So better give it a try. So this is the question. As you can see, it's about limits, and it is limit n tending to infinity k equal to 1 to n 1 minus tan to the power 4 pi by 2 to the power k. So let's get started with the hints. I hope you have given it a good try. So these are the following hints for the problem, and as you can see, the first hint of the problem is that tan of 2 theta is equals to 2 tan theta by 1 minus tan squared theta, and thereafter simplifying for 1 minus tan square theta. So why do we require tan of 2 theta, or how did we approach to tan of 2 theta other than not just simplifying as 1 minus tan square theta? So the thing here it's just because of the following. Let me just note it down. As you can see the question, it is given that tan of 10 to the power 4 pi by 2 to the power k. So in the question, as you can see, the argument of the value of tan theta is a decreasing GP. Right, wait a minute, just a minute. This page is just wobbling up and down. Yeah. So this is a decreasing GP with a common ratio CR, let's say CR of 2, common ratio of 2. It's pretty much clear. So we need to find a factor of 2 in tan of theta, right, which can be useful. Also, if you see the problem, it's given that 1 minus tan to the power 4, let's say it is theta k, and where theta k is equals to pi by 2 to the power k, right? I have assumed this variable, let us say. So as you all know that it is just equal to 1 minus tan squared theta k times 1 plus tan squared theta k, right? So, and in tan of 2 theta, we all know that it is just equal to 2 times of tan of theta divided by 1 minus tan squared theta, right? So we all know this thing, right? The tan of 2 theta, expression for tan of 2 theta. So I can just substitute the value of 1 minus tan squared 2 theta, tan squared theta, just by replacing the numerator and denominator of this. So that's what I have done in the first hint, as you all can see. For the second hint, I have just substituted the value of this, right? I have just written the value. I have not explained anything. For the second hint, I am talking about this one. So it's just nothing, and most of you will be familiar with it, right? It's pretty straightforward if you have done some questions on limits and also on some trigonometric questions. So erasing a part of it so that we can get the space out of it. So what we were given was cos of theta into cos of 2 theta into cos of 4 theta up to cos of 2 to the power n minus 1 theta. So what we can do here is we can multiply 2 sin theta in the numerator and a 2 sin theta in the denominator, which on multiplying with it, wait a minute, which on multiplying, as you can see, this term right here, right, this term, it's just sine of 2 theta. I can write it, and I can further continue the cos series, that is cos 2 theta into cos of 4 theta into up to like n minus 1 2 to the power n minus 1. But also in the denominator, remember that we have a 2 sin theta. So what will I do again is that I will just multiply a 2 here in the numerator, and again this part comes out to be sine 4 theta, which will again club with cos of 4 theta, right? So we have also we will also multiply the 2 with the denominator also, so that it cuts down to equal to 1. So we can also replace this denominator of 2 by 2 to the power 2. We can do it, and we know that this will continue, and we can finally get the value of it to be cos of 2 to the power n minus 1 theta into 2 sine 2 to the power n minus 1 theta divided by 2 to the power of n sine of theta, which will be further simplified to give sine of 2 to the power n theta divided by 2 to the power n into sine of theta, right? And that's what I have written in the second hint. So this is the derivation for the second hint, as you all can see. You may write it down or note it down in your copies if you didn't know it earlier. I'm just erasing it. You may pause the video to write it down, okay? So for the second hint, as you can see, we have mentioned the derivation, and now for the third hint, I just simply mentioned it in the first one only, that we will just simplify the expression of 1 minus tan to the power 4 theta as follows, by breaking down into a squared minus b squared format. And also for the fourth hint, if you see, for the fourth one here, right here, the fourth one, it is just that the basic of limits concept. It's the fundamental limit concept that tan of theta by theta as theta tending to 0 is equals to 1. So I just rearranged the expression to a better format, and most of the JEE students will be knowing it pretty much, because in physics it is very much useful that tan of theta is being substituted with theta most of the time in the problems. So yeah, let's move on to the next question, next part of the problem. So for the next part, before that you may try the problem again. If you haven't solved it yet, you may try the problem. I will be just moving on to the next part so that for the other viewers it's easy. So just written the hint number 3 again, right? Copied it down. Hint number 3, I just copied it down here. So in the problem, as you can see, we were given the so do not try to read it alone. Let me just guide you through it. So as you can see, I have just written the problem. Okay, it's nothing pretty big. It's just writing the problem again so that we are familiar with it. So this was a problem, right? That is product of k equal to 3 to n 1 minus 10 to the power 4 pi by 2 to the power k. So what I have done at first, I have assumed theta k, a variable theta k, which is equals to pi by 2 to the power k. What I have done after that is that I have broken the problem into two parts. Right? I have broken it into two parts. The first part of the problem is about simplifying 1 minus tan square theta k. And the second part of the problem is about simplifying 1 plus tan squared theta k. Right? So moving on to the first part of the problem. Yeah. So as you know, we have assumed that theta k, a variable, is equals to pi by 2 to the power k. So let's just experiment it a bit by multiplying 2. So we know that multiplying it by 2, we will reduce the denominators. In the denominator, the power of 2 will be reduced by 1. So we can just write by the following expression that 2 theta k is equals to theta of k minus 1. Right? We have just written this expression by the help of our variables. Now, let us denote the following term, that is 1 minus theta squared, 1 minus tan squared k, as ak. Right? We have let assume this. Now the problem simplifies to the following expression, that is product of ak. Looking a bit simple, right? Now again, we know that ak is also equals to 2 of tan theta k divided by tan of 2 theta k. Now we also know that 2 theta k is equals to theta of k minus 1. So we can just simplify it a bit so that the expression looks a bit more beautiful. So this is the expression for ak finally, that is 2 tan of theta k divided by tan of theta k minus 1. Now the problem is a telescopic sequence, right? Do you know what is a telescopic sequence? So for those who don't know it, it's just a huge sequence that is given. It just simplifies by same terms. The same terms cancel in the numerator denominator, so that giving a final expression of very simplified final expression, right? So this is a final expression that we get, that is 2 to the power n minus 2 into tan of theta n. See, here it is theta n, tan theta n, and from the denominator, for the denominator we will get it from here, that is tan of theta 2. So we get tan theta 2 in the denominator. Now we earlier assumed that theta k is equals to pi by 2 to the power k. So therefore theta 2 will be equal to pi by 4 and theta n will be equal to pi by 2 to the power n. Right? Now there is a note here that theta n, try to grasp this on your own because it will help you a lot to build a mathematical skill. So this is limit of n tending to infinity theta n, this part right here. If we just see, limit of theta n tending to infinity is equals to 0. Right? So by the help of the hint number 4, we can say that limit of tan theta k as k tends to n. Right? When k is tending to n, theta k will also tend to 0. So that is the motive of us to derive the value of tan theta n is equals to theta of n. Right? We derive that tan theta n is equals to theta n as the limit of n tends to infinity. Right? We deduce this problem, deduce this expression. So moving on, we can further say that the following expression, that is limit of ak, product of limit of ak, can be written to be equal to 2 to the power n minus 2 into tan of pi by 2 to the power n divided by, in the denominator, tan of pi by 4. Now tan pi by 4 is just equal to 1. We all know this. The tan pi by 4 is equals to 1. And as we have mentioned it in the hints earlier, just now, that tan of pi by 2 to the power n is just equals to pi by 2 to the power n. So we can just write it down as the answer to the first part of the question as pi by 4, right? Now this was a pretty amazing thing, right? We simplified a huge expression by breaking down into two parts. Now for the second part, if you see, for the second part, let us assume that the terms are denoted by bk, right? And bk is equals to nothing but 1 plus tan squared theta k. So 1 plus tan squared theta is equal to secant square theta. We all know this. And sec theta is equal to 1 by cos theta. So I just have written the value of bk, product of bk, as in the terms of cos theta, right? Now I just mentioned the hint, in the hint number 2. You may check out the hint number 2 if you haven't seen. So the hint number 2, I have already mentioned the derivation for the following part, right? And the derivation, according to the derivation, the total number of terms here, that is the total number of terms in this, is equal to n minus 2, and hence the power of 2 will become n minus 2 and not n in this problem. So on simplifying this further, we get the value of product of bk as pi square by 8. And also we need to know this property of limits, that this is a amazing property of limits, that the product of two individual limits can be written down as the product of one single limit if the limit, the value of k tending to infinity as it is given here, is same. Like if it is given that limit of k tending to n times limit of bk k tending to n, if the tending limit, that is the number or the value to which it is tending, is same, then we can just club the terms together so that we get the value of this as ak into bk k tending to n, right? So finally the answer to the problem for today is just pi cubed divided by 32, and that's the answer to the problem. Hope you like the question. Please do share and like the channel for more such questions and amazing concepts. That's it for today, guys.